Okay, on this particular side of it, now we're going to have problems that look like this. Let's say x squared plus 4 equals 0. Now you're going to solve for x. So this is very similar to what we had in section 1. The difference is that when we do this, we have to do one extra piece that we didn't have to do on section 1. How do I solve this? Do you want to A, factor, or B, use square roots?
Square roots.
And you can for this one because it's just x squared. So what do I do first? Subtract 4, right? So I got x squared equals negative 4. And then what? Square root it. Now, a few days ago, you would have looked at that and said, nope, can't do it because it was no real solutions. But for this stuff, we're not finding real solutions this time, we're finding all solutions. So how do I treat the square root when it's a negative? What do? Take your I out first, right? And then what's the square root of 4? 2. Now, if you told me it was 2i, you're half right. What are you missing? Plus or minus.
So now you have to do plus or minus?
When you're in an equation, yes, Tamara. When you're not in an equation, when it's just an expression and asking you to simplify it, no. When it's an equation where you're putting the square root in there to solve for an x, yes. Okay. Okay, what do? Add the 11. What's negative 47 plus 11? Negative 36. Now what? Divide by 2. And what is negative 36 divided by 2? Negative 18. Now what? Square root it. And the square root of a negative, remember, what do you have to take out first? I. And then can the square root of 18 reduce? Yeah, I hope so. Maybe, maybe not. Does 2 go into 18? How many times? 9 times. Does 2 go into 9? No. Does 3? How many times? Now, when I'm doing this, just so that you guys understand this is just one option. Some of you have asked me, do I have to do it this way? Absolutely not. If you knew what the square root of 18 was to begin with, great. Awesome for you. This is just one technique of doing it. You do not have to do it this way. Now, some people are also confusing it. The number that gets circled goes outside. The number that doesn't get circled stays inside. So what number goes outside? 3. And what number goes or stays inside? Oops, I forgot the I, Allie. That's not good, is it? Not when it's supposed to be there.
Wait, can you put the I after like the 2?
Yeah, that's another good question Savannah just asked. Can I put the I after the square root of 2? Yeah. Why? Do you know what property that demonstrates? One of the properties that you have in math when you're multiplying, if you multiply in a different order and it still stays the same answer, is called the commutative property. I can put the I wherever I want. Just be careful not to put the square root over top of the I. And that's what a lot of people do, is they accidentally put the whole thing underneath it. When really the I should be outside. Most of the time, you'll find it in front of the square root. But it's not wrong if you put it behind it. Okay, what are you going to do? Minus 33. That's sounds like a great step to me. What's 3 minus 33? Negative 30. Is it important to have the sign correct? Yeah, because what happens if you don't? It's wrong. Okay, so now what? Divide by 5. And what's negative 30 divided by 5? Bless you. Now what? Square root. And I get what? What's my final answer? Plus or minus, so I'll give you that part so far. I, and then the square root of 6 does not reduce because that's 2 times 3, and that's it. What do you guys think of that so far?
Easy.
Okay, now on today's stuff, just so that you guys know when it says to factor it, or it's not going to say factor, it's going to say solve it, there's no factoring because it's really hard to factor when you have I involved. So for the ones that you're going to have today, it's going to be just like this. Get everything to one side, square root both sides, you're more than likely going to have an I. Could you have problems that don't have I's? Sure. But in all likelihood, you're probably going to have an I. Then, the only other thing that it'll have is it'll say f of x equals 4x squared plus 20. And the directions for this will say find the zeros. You've done this 2 ways already. Actually 3 ways. You've done it with a graphing calculator, finding it where it crosses the x-axis. You found it by square rooting, and you also found it by factoring. If you try to graph this one, just so that you guys know, it's not going to cross the x-axis, so you're going to say, well, it doesn't have a 0. It doesn't have a real 0, but it does have imaginary zeros. So when it says find the zeros, take f of x out and replace it with a 0. And now, what's different about this problem as compared to the ones that we just did 3 of them? Is there anything different? No. You solve it the same way. How do I solve for x? Huh? Minus 20 first. Negative 20 equals 4x squared. Divided by 4. What's negative 20 divided by 4? Negative 5. Now how do I get rid of the root, or square? Square root it. So I got x equals, what's the square root of negative 5? Plus or minus I square root of 5. Are you guys okay with that?
Yeah.
Do you want me to do another one? Huh? We've had factoring before, but Tamara, none of these are going to factor for you today.
Okay.
So you're not going to have to worry about it. All right. So looking at page 109, just to read you through the directions, it says on 49 to 54, it says solve the equation, and it's just like what we've been doing. And then 55 to 62, it says find the zeros. 63 and 64, it wants you to tell me what they did wrong. Then on 69 to 73, it says write the expression as a complex number in standard form. That is exactly what we did yesterday. You're going to have to combine like terms. You may have to multiply first, but then you're going to combine like terms. That's what that little section's about. A little bit more complicated problems than yesterday's. Okay? But we do need to go through one other thing before I forget on there, because there is stuff that happens. When you have I, you guys told me yesterday, or I told you yesterday, that it was equal to the square root of negative 1, right? What did we say I squared was? I squared equaled negative 1. So now what we need to talk about is what happens when that exponent is higher than that. So what's I to the third? Now, before you start guessing, because you don't know, when you're dealing with exponents, the rules for exponents is if you multiply 2 things with the same base, you can add exponents. What 2 numbers add up to be 3? 2 and 1, right? So I to the third is really like saying I squared times I. Because 1 plus 2 equals 3. But what was I squared? Negative 1. So it's really like saying negative 1 times I. What's negative 1 times I? Negative I, good. So now I'm going to do I to the fourth. What 2 numbers could add up to be 4? 2 and 2, 3 and 1. 2 and 2 is easier. If I say that that's the same as I squared times I squared, what's I squared equal to again? So I'd have negative 1 times negative 1. What's negative 1 times negative 1? Positive 1. Anytime you have an exponent higher than 2, it's going to reduce down into either having an I with it or not an I. It's going to either be a whole number or it's going to be an I. Okay? Now, I to the 5th. What two numbers can add up to be 5? 2 and 3. What else? 4 and 1. Or I could do 2, 2 and 1. Right? If I wanted 3 numbers. But I to the 4th times I to the 4th was 1. I was I. What's 1 times I? I, 1 times I is I, right? Anything times itself is, or anything times 1 is 1. Or, you know what I'm saying. Anything times 1 is itself. There you go. So what's I to the 6th? Okay, what two numbers would add up to be 6? 3 and 3, or 5 and 1, or 4 and 2? Those are easier. I to the 4th times I squared. Well, I to the 4th was negative 1, and I squared was positive 1. What's negative 1 times positive 1? Negative 1. Okay, maybe you guys see it. Maybe you don't. What numbers would add up to be 7? 4 and 3? Huh? What repeats itself, Tamara? Tamara noticed it finally. Thank you. There is a pattern. Okay? Here's what the pattern actually represents. I'll write it down a little bit neater. I itself equals I. I squared was equal to negative 1. I to the 3rd was equal to negative I. I to the 4th was equal to positive 1. And then she said it started repeating itself. I to the 5th, you said was I. I to the 6th was equal to negative 1. I to the 7th would have been equal to negative I. And I to the 8th equaled positive 1. And I can keep going, right? That's the way the pattern works. Every fourth thing, there's only 4 different options. Every time I go through an option of 4, I'm going to get the same numbers out. You will never have an I higher than I. You will always be able to reduce it down to either I or to a whole number. You cannot leave it as I to the 5th or I to the 3rd or anything like that. Always reduce it. In my college algebra textbook, there's this problem. I to the 1002. Now, I do not expect, if you had a problem like that, to actually list out all the way to 1002, because you have better things to do with your time. So here's how you reason it out. Use some reasoning skills. If that's an even number, according to what Tamara noticed, and she was right, that it's a pattern, all even numbers are either which two numbers? 1 or negative 1. It's got to be one of those two. So right now what I'm doing is I'm narrowing down the options. I know it's either going to be one or the other. Now, in order to figure out if it's positive 1, that was 4, that was 8. If I go to the pattern, that would be 12, 16, 20. Those are all multiples of 4. Is 1002 a multiple of 4? All you have to do is take 1002 divided by 4. Does it come out evenly? No. If 1002 is not a multiple of 4, then it has to be one of the other even numbers. So this would actually be equal to negative 1. Then, another problem that's in my book for that is this problem. I to the 243. Here's how I treat it. I go up to the very next one, which would be 244. Is 244 divisible by 4? It is. So this one would be positive 1. What's 1 previous to that in the pattern? Negative I. Okay? That's all those are. The highest exponent I see in that little spot is I to the 5th for you guys. That's the highest one I see for that. Okay? So again, the first little set, you're just going to find the solutions. You have to take your eyes out. And then the last 3 questions, you have to combine like terms. Just like you did yesterday. Okay? What do you guys think? So on page 109 to 110, we're 49 to 63 odds. And 69 to 73 odds.